In this video, I'm going to show how you can graph using roots. Well, roots and intercepts. Really, what I should say. First thing I'm going to do is I'm going to look at this value here, and this value here, and I know the possible solutions are going to be factors of 8 divided by factors of 1. So I'm going to use synthetic division to look for some possible solutions. And the first number I'm going to try is, I'm going to try 4. So bring down my 1. 4 times 1 is 4. Negative 2 plus 4 is 2. 4 times 2 is 8. Negative 4 plus 8 is 4. 4 times 4 is 16. That gives me a remainder of 24, which is useful in knowing, but it's not really going to help me out. So I'm going to try another value, and it's quite big. F of 4 is 24, so I'm going to try a value like 2. Bring down my 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Negative 4 plus 0 is a negative 4. 2 times negative 4 is negative 8. And that's perfect, because that gives me a remainder of 0, which means 2 is a solution. Since 2 is a solution, and we started with the third degree polynomial, that tells me that I can drop this down. This becomes 1x squared plus 0x minus 4. I'll set that equal to 0. And the reason why is because that gives me x squared minus 4 equals 0. And if I factor this as the difference of perfect squares, I'm going to get x equals plus or minus 2. And so I'm going to write down f of 2 equals 0 again, and f of negative 2 equals 0. And the reason why I'm doing that is because I did end up with 3 solutions, 3 roots. But 2 of them are the same, and this is significant. And I'm going to explain why in a minute. There is one other value that I want to point out, and that's that f of 0 equals 8. And the reason why is, if x equals 0, I get 0 cubed minus 2 times 0 squared minus 4 times 0 plus 8. These will all go away. You're going to be just left with 8. So now, I'm going to put down my roots. There and there. I'm going to put down my y-intercept. Now, the other thing that I think is always important to know is what f of x equals x cubed looks like. And this is why having this general knowledge is always very good. The graph of f of x equals x cubed always starts below the x-axis and always ends above. So, although I'm not 100% sure what this is going to look like, it should look something like this. And you might say, well, how on earth did you know that it turned at 2? And the reason why I knew it turned at 2 is because when we did the synthetic division and then we factored, we found out that these two values were the same. And that means that it's not going to go below the x-axis here, but it actually turns. So our local minimum point is 2, 0. Our local max appears to be 0, 8, but that's not actually accurate. If you take a look at your graphing calculator and you select 2 points to check between, you'll find out that your local max ends up actually being negative 2/3 and 9.4814. That goes on and on. We were just looking for a general sketch of what this should look like, and we were only off by a tiny bit. The key thing is that you know where your roots are, and if you have a turning point such like that. It also helps, like I said, to know this. This is actually really, really important. We started with synthetic division, found some solutions, found our y-intercept very easily, and that's it.